All right, so what are we going to be talking about today? Well, our talk can be pretty much divided into 3 different parts. So first, I'm going to be talking about a general overview of geolocation. I'm going to talk about some code, for example, how to do this in a mobile app, and then talk about some common classes of vulnerabilities that we see that might leak user information or user location. I'm then going to talk about some actual applications that are in the App Store that either were or still are vulnerable to these geolocation vulnerabilities. I'm going to hand it off to Colby, who's going to go through a case study, basically talk about a very popular app that had a myriad of geolocation bugs that when we put them all together cumulatively, we were able to track any of its users anytime, anywhere in the world. And then finally, because we want to have some good suggestions, we're going to describe some fixes and then have a brief conclusion. All right, so first an overview of geolocation, some code, and some interesting bugs. Now, this is probably an obvious statement, but geolocation in mobile apps is pretty much the norm. Most apps that talk to the cloud or the internet have some sort of geolocation capability built in. And also users are making use of this. So the graph on the left, you can see that almost 3/4 of smartphone users have used geolocation, the geolocation capabilities of their phone or in apps. And they use this for a variety of reasons. You have the obvious stuff like navigation, health and fitness, it'll track where you run, recommendations, things like Yelp, what's good nearby. Social apps are a big one, Facebook allowing you to post or tag where you're at. There's actually apps specifically in Android that allow people to track their kids. I didn't realize this, but I guess that's a use of geo. And then commerce is actually kind of up and coming, and this is where banks or other people are basically using apps to say, hey, you're nearby our store, here's some coupons or something. So it's really, really common. So implements logic. All right, so that concludes the kind of common classes of geolocation bugs that we see a lot. So I want to talk about some real-life examples. So these are some actual apps that did or still do compromise a user's geolocation information. So the first one is Starbucks. It's kind of funny. You don't think, why is Starbucks tracking me? But older versions of the Starbucks app stored users' geolocation coordinates in an unencrypted file called session.clog. So again, this is problematic if the phone was lost or stolen, because it can provide an attacker with a wealth of information about the user's location. Luckily, this was reported, received a CVE, and was patched, so current versions are not vulnerable. Whisper is a secret sharing app that claimed to be the safest place on the internet. Now, it had a UI bug or feature that even if the user opted out of sharing their location, this information was still sent to the app developer's servers, the API endpoints, and then according to The Guardian, this was shared with a bunch of people, including the DoD. So this is an example of a UI bug where the user might say, I turned off location sharing, why is it still sending? And Whisper might be like, well, we're not sharing it with other users, but we are just sharing it with the DoD. So this is an image from the Guardian report. It's a place called Fort Med or Fort Meade or something. So I Googled this because I didn't know what this place was, and apparently there's some intelligence stuff going on. So I was really surprised why everyone was whispering about stuff. So in this case, I may be okay that the DoD was getting access to this information, but yeah, kind of crazy. All right, so Tinder is another example. It's a very popular dating app. I'm married, so I don't know these things. But it provided exact geolocation coordinates to the API endpoints and then to other users. This was reported to Tinder, so they're like, all right, we won't do this anymore. So then they went to providing relative locations, which is susceptible to a trilateration attack, which Colby will talk about later. Also, since it was integrated with Facebook, there were some APIs that you could call that would give some very specific information about the user's Facebook account that then you could go and tie your matches to their Facebook page. So this was publicly reported and patched, but before this, there may or may not have been some applications called Tinderizer, which would allow you to put in your username and password, and then it would get all your matches, put them on a map exactly where they were at, and then link them to all their Facebook profiles. So, not good. Well, maybe. All right, so the last app I'm going to talk about is Angry Birds. And again, this is really interesting to me because this is an example of an app that you would not think would be collecting your locations. But it turned out that it was, and that it was not securing the network comms that were being reported with the location. So it turns out that, again, this illustrates that geolocation is everywhere, even in apps that you might not suspect. And if it leaks, it turns out that people were collecting this. So that was a little surprising. I blame it on the pigs, not the cops in the game, the little pig guys. So be careful there. All right, so Colby now is going to talk about an app that was vulnerable to a myriad of geolocation bugs that, when we combined them, cumulatively, they allowed us to track any of its users anytime, anywhere in the world.
Thanks, Patrick. So we've talked about how these location vulnerabilities occur, but what are the real-world implications? We surveyed a lot of applications out there and decided one called Grindr was an ideal candidate, really due to its ridiculously bad misuse of geoinformation. So what is Grindr? It's the largest and most popular all-male location-based social network out there. More than 5 million guys in 192 countries around the world and approximately 10,000 more new users downloading it every day. Bottom line is that the app is based completely around knowing who's near you. It's extremely popular, and it caters to a demographic that has a history of being targeted. So we figured it'd be good to take a look from a user privacy standpoint. To begin our assessment, we checked to see if there were any previously publicized vulnerabilities, and sure enough, there was. In 2012, a vulnerability was discovered that allowed impersonation of users as well as sensitive data compromise. In 2013, a graduate school paper revealed more concerns around user enumeration, impersonation, and identification. In 2014, we published our assessment, which was the first to bring up the issue of location privacy, which we'll talk about more in a minute. And then in late 2014, someone else caught on and leaked similar vulnerabilities to Pastebin, and we'll talk more about this later. So what did the developers do wrong? There's no SSL pinning in the mobile application. Geo is provided with way too much precision. Location spoofing to the server is trivial. The APIs are overly permissive, and all data was filtered at the UI level. So basically everything Patrick just talked about. The first bug that we noticed was that the iOS application didn't pin its SSL certs. So Patrick talked about this earlier, and it makes it much easier for an attacker to pull off a man-in-the-middle attack and to sniff credentials as shown here in the screenshot. Using a man-in-the-middle proxy, we're able to take advantage of this lack of SSL pinning to examine the application's protocol in detail and reverse engineer it in order to build a custom client. Bug number 2. Upon running the app, it queries the server and pulls down a series of JSON blobs for each user nearby. And each blob is all the user's profile info. The problem here is that the distance field provides us with an extremely precise relative distance. This distance here is shown down in kilometers. It's shown down to the sub-centimeter level. So, yeah, I mean, the GPS isn't even that precise, but that's how long the decimal goes. So this opens up the possibility for our trilateration attack, which we'll talk about here in a little bit. So we reported these bugs to Grindr a long time ago, and they made some changes. Unfortunately, their changes had little effect. Looking at the disassembly of the newest iOS Grindr app, we see that location privacy is set to 10 meters of precision. The problem here is that, A, 10 meters of precision is still enough to identify where someone lives, works, or is. And B, with this setting, you're guaranteed that the result is within 10 meters of precision, not a location with 10 meters of error introduced. And so we found that the iPhone generally returns accuracies on the order of 3 meters of precision for the setting. So that's still really good. So random error should have been introduced server-side and not relying on this feature. The image here shows Patrick in his office testing the app, and the location was literally within about 3 feet of where he actually was. So furthermore, no authentication was required to talk to these APIs, like none at all. The amount of queries and the amount of queries weren't limited. It was pretty much a dream for somebody who wanted just to scrape a ton of data. It became trivial to enumerate users and pull down everyone's profile info containing name, height, weight, age, relative distance, social media links, and even photos. So Grindr has since implemented and required authentication. However, signing up takes just seconds, and your email isn't verified. So bypassing this is trivial. So while examining the JSON data from some other users, we noticed something odd. There was a key titled show distance, and sometimes this was set to false. But distances were still in the JSON data. So it turns out that the UI level logic was deciding whether or not to display the data. In short, data was still being broadcasted to everyone, just not displayed. So with a little bit of technical savviness, it wasn't hard to kind of tap in and view it. So here you can see that it was just a toggle switch showing how it was implemented in the application. And then, okay, so we've got all these seemingly minor vulnerabilities in the app, but like, what could a real-world attacker do with it? So we decided to write a framework to leverage these bugs, like, just to find out for ourselves, what's really possible. Before we go any further, I should note that the purpose of this research was not to identify Grindr users, but to help protect those who wish to remain private. That during vulnerability research and disclosure, no individual users were intentionally or unintentionally identified, and all data has been irrecoverably destroyed. So based on these bugs we found, we theorized that we should be able to track any user at any given time. The APIs are wide open, we get extremely precise geo information, and location spoofing was trivial. So now that we're able to suck down user information and determine what users are nearby, we need a way to locate them. So to do this, we gather distances and implement a basic trilateration algorithm. Now you're wondering, what is trilateration? Trilateration is the method of determining an absolute location based on 3 or more relative distances. So if we know a user's location from 3 different spots, we should be able to calculate precisely where they are. So first we spoof our location 3 times around a location of interest, a city, San Francisco, DC. And we query users' relative distances from each point. And due to the Earth being a sphere, distances are measured along the circumference, so we have to convert the distances received accordingly. We map them to a spherical coordinate system before we run any other calculations. Ultimately, after a lot of math, we're able to determine users' precise coordinates. So here's an example of, kind of how our script works in the end, exactly where they are. So now that we have a way to determine location, let's run it on a massive scale and track some users. So here's some screenshots from our mappings early last year. So shown here is San Francisco and the Sochi Olympics. So just as a sanity check, you can see that all the users fall within the land masses and tend to be in densely populated areas. So we're pretty sure we got it right. So this starts bringing up some really interesting privacy issues, especially for prominent figures that may be Grindr users. What if you're an athlete, a politician, a movie star, and you're using Grindr data anonymously? You might not want the media or public involved in that side of your life, especially if you wish for your sexual preferences to remain private. It's very conceivable to think that someone could watch a specific location, such as a US Capitol or shopping centers or whatever, to determine a specific user's identity. So to test our theory, we tracked some willing users over the time span of a week. Sure enough, patterns began to emerge. More often than not, we observed that for each user, there are dozens of data points in 2 distinct locations that occurred at 2 distinct times during the day. And we could infer that these were kind of home and work locations, respectively. And so occasionally, you'd say pit stops along the way, maybe the gym or the grocery store, but predominantly it was home and work. So in the screenshots here, you can see the kind of accuracy we're receiving, really down, inside of a house or at a specific location. So let's take it one step further. We know we can track you, but who are you? So first we have the geolocation information, which tends to be scary accurate. So combining public record sources such as home ownership databases for home locations and LinkedIn profiles for work locations, it became really easy to guess who works and lives in a specific area. So to validate identities, Grindr users tend to share lots of personal information as well, including name, photos, age, height, etc. So not to mention a large percentage of users linked to social media. So it was really easy to kind of narrow down who's who. We conducted tests using this method on several willing participants and had nearly 100% success rate in truly determining identities. So even if you wish to remain anonymous, which a lot of Grindr users do, we're still able to deduce the identities of these people. So, all right, so as a location-aware app developer, what can you do to not fall in this trap? And as for your users, what can you do to protect yourself? Users, assume that you can be tracked. Accept it as a fact and act accordingly. If you're really paranoid, drill down into the location preferences in your phone and turn off location sharing for apps at the OS level. Developers, you really need to be sure you're implementing your secure comms correctly. Use SSL, pin your certs, make sure it's right. Protect your APIs. Implement rate limiting. Make sure someone isn't hopping from Africa to London to the US. Use correct UI logic. It's not that, just don't filter in the UI. Do it server side. Use secure local storage. And don't use any more precision geo than you need. You know, maybe to the nearest 100 feet is good enough for you. So thank you all for coming out and attending our talk. Feel free to reach out to us.